Today we're starting on page 6 of our chapter 4 notes, and we're actually going to cover just pages 6 and 9. So section 4.3 and 4.4, linear functions, direct variation, and absolute value functions. Some functions have special properties. A one-to-one function is a function such that each y value comes from one and only one x value. Or in other words, a function is said to be one-to-one if no two ordered pairs have the same second element. And we also know when we're looking at a graph and whether a function is one-to-one, we can use the horizontal line test. The function y equals x is one-to-one. The function y equals x squared is not one-to-one. Why? Well, y equals x, if we just sketch a graph of y equals x. Y equals x is a line that actually bisects the first and third quadrants. Okay, so this is the graph of y equals x. So we know it is a function, passes a vertical line test, and it is one-to-one because it passes the horizontal line test. Passes VLT and HLT. So it's a one-to-one function. The function y equals x squared is a parabola. Turning point is the origin. So here we have a graph of y equals x squared. It is a function. It is not one-to-one. Right? Fails the horizontal line test. Or in other words, if we take a value for an x value of 2, would result in a y value of 4, but also an x value of -2 would result in a y value of 4. So x values of 2 and -2 have the same y value. So it's not one-to-one. Just a reminder, we can easily tell if a graphed function is one-to-one by performing the horizontal line test, which we did above. Remember the vertical line test to determine if a relation is a function. In order for a function to be one-to-one, it must also pass a horizontal line test. So here we have the graph of y equals 2x minus 1. It is a function. It is also one-to-one because it passes. In order to be one-to-one, it first has to be a function. Okay, you cannot have a relation that's one-to-one. Only a function can be one-to-one. An example here, we have y equals the absolute value of x. The graph is drawn, and it is not one-to-one because it fails the horizontal line test. Fails the HLT, so it's not one-to-one. Another special classification of functions is called onto. A function is onto if each member of the range is mapped to a member of the domain. In other words, every element in the range is used. In the above graphs, y equals 2x minus 1 is onto, while y equals the absolute value of x is not onto. Right? So let's go back to this. In order to be onto, the range and domain would have to be the same. So if I go back and look at the domain and range for y equals 2x minus 1, and just pretend that this continues on, okay, that there's arrows at the end of this line. So our domain is all real numbers, right? All our x values, all right? This keeps going outward to the left and upward and outward to the right. So our domain is all real numbers. And our range, lowest point to highest point, right? This keeps going downward to negative infinity, upward to positive infinity. So our range is also all real numbers. So this function is onto, whereas y equals the absolute value of x. What's our domain? Okay, again, let's put arrows at the ends here to show that this does continue. So our domain, leftmost point to rightmost point, this keeps going outward to the left and outward to the right. So our domain is all real numbers. And our range, we do have a lowest point here. It's y value of 0. Okay, so our range is, if I'm using interval notation, 0 to infinity. Does our domain and range match? No. So y equals the absolute value of x is not onto. In the next set of diagrams, the mapping from A to B is onto, while the mapping of set C to D is not onto. Right. See, from A to B, all the members of the range are used, and from C to D, they're not. In fact, the mapping from set A to B is also one-to-one. It can be called a one-to-one and onto function. Now we're skipping pages 7 and 8 and going to page 9. So page 9 of the notes next. So turn to page 9. Direct variation. When the ratio of two variables is constant, we say the variables are directly proportional, or that the variables vary directly. Two variables that are directly proportional increase or decrease by the same factor k. Every direct variation of two variables is a linear function, linear line, passing through 0, 0, passing through the origin. So if you have a line that's passing through the origin, that is a direct variation. That is a representation of a direct variation. The equation for direct variation, for direct, because later on we're also going to have inverse variation. For direct, think of divide. The equation for inverse variation, oops, sorry, that's coming up. The equation for direct variation is y divided by x equals k. Now, if we wanted to solve this for y, we would simply multiply both sides by x, and we would have y equals k times x, where k is some constant. Now, on this page, what we're going to do questions 13, 17, 16, and 20, right? So the direction, this came right from the textbook, but everything's typed out for us. What we need to do here is to graph the function. It says A, graph the function. B, is it a direct variation, yes or no? C, is it one-to-one, yes or no? And then state the domain and range. All right, so we have the equation y equals 3x. We're going to sketch a graph, so just draw a small x and y axis. Y equals 3x. Well, this is y equals mx plus b form, so I know my y-intercept is 0. This is just because I've had a lot of practice over the years graphing linear equations. And I know the slope is 3. So I'm going from 0, 0, I'll go up 3 over 1, up 3 over 1. All right, so we have something maybe like this, right? Y equals 3x. Is it a direct variation? Is it a line that passes through the origin? Yes, it is. Is it one-to-one? Does it pass the horizontal line test? Yes, it does. It passes horizontal line test. What's the domain? All right, keeps going downward to the left, upward to the right, so the domain is all real numbers. Same for the range, all real numbers. Number 16, y equals 8 over x. Alright, well y is by itself. It's not our usual y equals mx plus b form, so we can go to the calculator and I'll key in 8 over x. And let me do a zoom 6 because my calculator was not set up for the standard window. Alright, so here we have, this is what it looks like. We have like two wings here. We have a curve in the first quadrant and a curve in the second quadrant, or not second, third quadrant. This is what we have. This continues on. All right, so this is a graph of y equals 8 over x. Is it a direct variation? No, it's not a straight line that passes through the origin. Is it one-to-one? Does it pass the horizontal line test? It does. What's the domain? Okay, now this keeps going upward, but does not cross over the y-axis. This keeps going to the left. So we have goes out to negative infinity. Here, this keeps going downward to the right, but does not cross over the y-axis. So in other words, it is all real numbers except the y-axis. And the y-axis is the equation of x equals 0. So it's all real numbers except x equals 0. So we have what's called a vertical asymptote there. All right, the y-axis is a line that the graph approaches but does not cross. And when we look at the range, right, we have the same thing with the x-axis. The range is all real numbers except y equals 0. Next, number 17, y equals 1/2 x. Okay, well that's y equals mx plus b form. I know what that graph is going to look like. Y-intercept is 0. It'll have a slope of 1/2, so I go up 1 over 2, up 1 over 2. It would look something like this. Is it a direct variation? Yes, it's a line that passes through the origin. Is it one-to-one? Yes. It passes the horizontal line test. The domain, all real numbers. And the range, all real numbers. And next, number 20. We have x over y equals 2. Let me multiply both sides by y, so I have x equals 2y. And then divide by 2. So y equals 1/2 x. Right? I want y by itself in order to go to the calculator and key it in. All right, but y equals 1/2 x turns out to be the same as what I just did in number 17. So let's just copy the sketch in 17. 1 over 2, so it's a line. Is it a direct variation? Yes, because it's a line that passes through the origin. Is it one-to-one? Yes. And our domain and range are still real numbers. Okay, so this concludes our video for tonight.